Hello, ladies and gentlemen. Today we're going to look at rotation of conics. The general form for any conic section is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And you can use the discriminant b squared minus 4ac to identify the type of conic. If b squared minus 4ac is negative, all right, then it will either be an ellipse, okay, or a circle. All right, now let's write down when it's which one. It will be an ellipse if, all right, b is not equal to 0 or a is not equal to c. All right, it will be a circle if both of those two things are true. It will be a circle if b is equal to 0 and a is equal to c. Okay. If that discriminant is equal to 0, you have a parabola. All right. If that discriminant is positive, it is an hyperbola. Okay. All right. The quadratic form of a rotated conic is a y squared plus by plus c equals 0. All right. Now, in example 1 here, it says use the discriminant to find the type of conic. All right, so a has a value, all right, in this particular conic section of 1. B has a value of -4. C has a value of -2. All right, excuse me. D, you don't need D, it's not involved, but if you wanted to identify D, it would be 0, E would be 0, and F would be -6, all right? But you don't need those for the discriminant, so I'm not going to write them down. I am going to go and evaluate b squared minus 4ac, where b squared is, or b is -4, and a has a value of 1, and c has a value of -2. Well, -4 squared is 16, and a negative times a positive is a negative times another negative is a positive, and 4 times 1 is 4 times 2 is 8, so that's 24. It's positive, so this is a hyperbola, okay? So hyperbola, since the discriminant is positive. All right, now, the next thing it wants us to do is to rewrite the quadratic in quadratic form in order to graph it on the calculator. All right, so what we're going to do is we're going to get it in a times y squared, all right, plus b times y, all right, plus c equals 0 form. Okay, all right. Well, we want something times y squared. Well, that's -2, so -2 times y squared, okay, all right, plus, all right, we want something times y, all right, and what we can do is factor out that -4x there, so that b would be -4x times y, all right, plus what's left is this x squared and that -6, and that will be your c. X squared minus 6. It is now in what we call quadratic form for a rotated conic. Something times y squared plus something times y plus something else. All right. And now please remember your quadratic formula. We're going to solve this for y. It would say y is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by twice the a value. Okay, so y would be equal to, the opposite of this b is 4x. All right, 4x plus or minus the square root of, well, b is still -4x squared minus 4 times a, well, a is the -2, okay, times c, which is the x squared minus 6. All of that then is divided by 2 times this a value, -2. Okay, Now you can clean that up if you want, and I do want to. So y would be equal to 4x plus or minus, all right, the square root of, well, square that, that right there gives you 16x squared. All right, a negative times a positive is positive, and that's 8. And that would be 8x squared, so plus 8x squared, and then 8 times negative 6 would be minus 48. Okay, all divided by negative 4. And I'll clean that up a little further because I can combine those two terms. Y would be equal to 4x plus or minus the square root of 24x squared minus 48, all divided by negative 4. Okay, now you can plot that in the calculator. I will tell you that immediately. Okay, we'll do that. We'll put them in the calculator. Let me just clear the RAM on this thing real quick. All right, so I'm going to clear that RAM, and I would go into y equals. I have a fraction, so I'm going to put in the. I'm going to do the plus first. I'm going to do 4x plus the square root of 24x squared minus 48, and then I'm going to divide that by negative 4. Okay, so there's the first part, and I'll go ahead and graph the other part as well. It is also a fraction, but we're going to take 4x and subtract the square root of 24x squared minus 48 before we divide that by negative 4. Okay, and then when we hit graph, we're going to have a hyperbola, excuse me, right here, all right, that has been rotated, okay? All right, so we'll hit graph, and you'll see the hyperbola that has been rotated. Now, for some reason, I don't think Texas Instrument gets it to close off all the way, but there is the graph of that hyperbola. All right, and if you want to put a few points on, you could. All right, let's do trace. Let's see. Let's do trace. And where is that cursor? I can't even see it. Okay, there it is right there. All right, so if we go back, first time I see it is there at about 1.5 negative 2. So about 1.5 negative 2 is this point. All right. And then if I go to the right, oh, there's a couple more points. Let's go down and get one down here a little further. 4, when we get 4, it's negative 8.7, 8.7. So negative 8.7, there's negative 8 would be that point right there. All right, and then I'm going to go back up for just a moment. All right, let's see if we can stay on that. Did it go to the other part yet? Oh, it's over here. Okay, well, it's still on this first part. Let's see, let's actually get that point closer to that vertex right there. That point right there is negative 1.5, 1. So you're looking at a point around in there. Okay, and now let's keep coming to the left. All right, until we can get a point pretty far with a negative. Let's go a little further. Oops. Negative 10. So when x is negative 10, the y coordinate is negative 2.1, which would be that point right in there. All right, now let's see if it'll go to the other part. There we go. Now we're on the other part, and you can go to the right. Where is it right now? It's still in the negative. Okay. All right, there's where you first see it right there. So negative 3.8. So that's very close to negative 4, and then 8, a little more than 8, which would be that point right there. So that branch of that hyperbola goes like that right there. Okay, all right, and now let's keep going to the right so we can get another point or two over here. And it should go up on the upper part over there to the right. We'll get as far over there to the standard viewing window as we can because that's what we've got here. Okay, so we're looking at about 9.8. Oh, there's 10. So when x is 10, you're looking at about 2.1, which would be this point right here. So that thing comes down like that right there and over like that. And there is your rotated conic. I'm going to tell you right now, I'm not looking for precise points because that would require some special calculations. All right, let's move on to example number 2. All right, use the discriminant. All right, this thing is already in ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0 form. All right, and you should be able to identify the value of a to be the coefficient of the x squared term, which means it's a 1. Okay, so a has a value of 1, b has a value of 1 also. Okay, and c is the only other one we need, so we're going to c has a value of 4. Okay, now you could find the other values if you wanted, but it's not necessary. So let's go and do a squared minus 4, b squared, excuse me, b squared minus 4ac. All right, b is 1, so 1 squared minus 4 times a, which is 1, times c, which is 4. All right, so that would be 1 minus 16, which is negative 15. Okay, all right, so that means if you refer back to the beginning, if it's negative, it's either an ellipse or a circle. Well, for it to be a circle, b would have to equal 0. Well, b is not equal 0, so it's not a circle. It is an ellipse because b is not equal to 0 and a is not equal to c. See, a and c are not equal. So this is an ellipse. Okay, all right, so now we're going to rewrite the equation in the standard a times y squared plus b times y plus c equals 0 form. Okay, well, what is the y? Here's the y squared term. So a is a value of 4, so 4 times y squared plus. There's two terms that have a linear y. That's this second and the fifth one here. And I'll factor the y out, so that would be y times what's left, which would be x plus 1. Okay, all right. Plus, what's left is x squared and the negative 4 plus the other, the x as well here. We would have x squared, so what's left, the c is x squared plus x minus the 4. Okay, and that still equals 0. And then we'll put that in the quadratic formula. Remember, it's the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by twice the a value. All right, so y would be equal to, the opposite of this term right here would be negative x minus 1, plus or minus the square root of b, which is x plus 1 squared, minus 4 times a, which is 4, times c, which is, okay, 4 times a. A is 1, excuse me. A is 1. Oh, the a right here. 4. And x squared, c is the x squared plus x. Don't get this. This is a, b, and c. Don't get that mixed up with the standard form. All right, just like I did. Minus 4, all divided by 2 times the a value, which is 4. Okay. Now, if you want to clean that up, you can. All right, or you can put it in. I'll clean it up a little bit. Negative x minus 1, all right, plus or minus the square root of, I'll do x plus 1 squared minus 16 times x squared plus x minus 4. I'm not going to do any more with that, divided by 8. Okay, all right. So now I'm going to put both equations in the y equals in the function editor. Okay. All right. So let me go into y equals, and I'm going to clear out the ones that we already had for that hyperbola. All right. And I'll go alpha y1 to get my fraction. I'll do the plus first. So negative x minus 1 plus the square root of, in parentheses, x plus 1 squared minus 16 times x squared plus x minus 4, close that off, all right, and then put in your denominator, which is 8, and that was the plus, all right. So now we're going to do the minus, all right, so negative, we need fraction first, excuse me, fraction, negative x minus 1, And we're going to subtract from that, so minus the square root of, in parentheses, x plus 1 squared minus 16 times x squared plus x, oops, that's not an x, back up, plus x minus 4, close parentheses, all divided by 8. Okay, now remember, we should get an ellipse. If we don't, we'll know we've done something drastically wrong. Okay, so let's hit graph. All right, and here is the ellipse that you should get. And it might help if we did zoom 0. I think that might put it on the screen a little better for you. Let's see what happens when we do zoom 0. And there's what that ellipse would look like. Okay, all right, that's the ellipse. And now let's actually get some points. Okay, all right, let's get a few points off of our calculator. So let's do trace. And it looks like we're up at the top up there. Okay, all right, and this is the plus we're on. And it looks like -1. Oh, it's decreasing. I'm going to go back. Oh, okay. -1, +1. That's up in here somewhere. All right. It's really close. Okay. That's that high point right there. Okay. Let's stay on that upper one and let's go to the right. Okay. So there's a point. Maybe like, let's go back. Okay. At 1.5, 0.1, which would be right in there. Okay. All right. And now let's go to the right some more. Notice it went down to the other part. Okay, and let's go back to the other part. Let's see, there we go. Okay, so we're on that part. If we keep going, all right, there we're over here at negative. Let's get this point right here. Ooh, let's go back right there. Okay, so -2.5, -2.5, and the y-coordinate is 1/2, so right in there. Okay, and now I'm going to do a zoom square because I don't think that thing was supposed to look more, I think it looks more like this right here, elongated like that right there, so that's what I'm going to do. And I'll do zoom, and we'll keep coming over here. Okay, all right, keep coming. Let's go back. Let's go down to the other part. That's what I need to do. Okay, I'll get a point down there, right in there, so like -1.7, -3/4, which would be about right in there somewhere. All right, and if I keep coming, here's a point where it might cross 0, -1.1, be right there. And I'll tell you, once you get that many points, you can just sketch it. It's going to look somewhat like that right there. Okay, and that's all we're expecting from you. All right, if you have questions, you can give me a call, show up in a Google Meet, or email me, whatever you need to do. Thank you. Have a good day.